will welcome Dr. Amarnath for this session. As per our invitation, Dr. Amarnath has accepted our invitation, and thank you very much, sir, for accepting our invitation. On behalf of Sectional Committee of ISL Chemical and Process Engineers, so we highly appreciate your commitment and giving us this opportunity to have a discussion with you, especially on the safety and technical aspects of the oil and gas industry. Yes, sir. Please proceed.
Actually, I think second time that I'm for ISL. I had a presentation in 2011. That was in Sri Lanka. So this is the second time I used. Yeah. So welcome to the today's webinar on personal and technical safety aspects in offshore and gas industry. So before we start the presentation, I would like to tell you a bit about my background. So I have a PhD in fluid mechanics from Norwegian University of Science and Technology, and I focused mainly on computational and experimental stuff of oil water flow.
Doctor, small concern. Your microphone, I think, is not properly. There is some disturbance.
Okay. Give me 1 second. I will change the settings.
Hello.
Yeah, wait a bit. I'll...
Yes, now it's better.
Now it's better?
Yes.
Okay. Yeah. Can you hear? Is it better now?
Yeah, it's better now.
Okay. In my PhD, I focus on computational and experimental investigations of two-phase flow in offshore oil and gas transport systems, and I studied for my master's degree in process technology at TUC, Telemark University College in Norway, and also I studied for my bachelor's in chemical and process engineering at the University of Malta in Sri Lanka, and I finished 2004. Now I'm working as a principal safety advisor at SafeTech Nordic Fires. I'm managing larger projects within risk analysis and technical safety for Norwegian and global oil and gas industries, or clients. So my key areas of work or competencies, they are with quantitative risk analysis for offshore platforms, and I have worked quite a lot with consequence modeling with CFD. When it comes to the oil and gas risk analysis, fire and explosion modeling. And I also work a lot with passive fire protection optimization. That's one of the very important area when it's come to oil and gas industry, because you have fire and explosion risk. So you need to design your process equipments and structural elements so that it can withstand the fire consequences. So optimization of passive fire protection is a very, very important area in modern offshore oil and gas industry, because you need to minimize the use of passive fire protection, and at the same time you have to improve the resistance of the process equipment and structural elements if you have fire exposure. Operational barrier management is also very important, because you need to ensure the safety not only in design but also in operation of your offshore platforms and other hazardous applications. I also work with the facilitation of safety workshops like HACID, HACCP, and ALARP workshops, and also have extensive experience in flow assurance modeling and leak, for example, leak modeling from pressurized hydrocarbon systems. In addition to my full-time position at SafeTech, I'm also having a part-time position as an associate professor in process technology at the University of Southeast Norway. So currently I'm supervising one PhD student and several master students, and also teaching 2 courses at the PhD and master level master students. My research interest is within multi-phase flow and technical safety and consequence modeling. So that is a bit about my background. And currently I'm working in SafeTech Nordic OS, one of the Norway's largest independent advisor in risk management. So company was established in 1984 and it's owned by employees. And currently we have over 150 employees in the company. And we have several office locations in Norway. We have actually 5 offices in Norway, 1 in Oslo and 3 in other major cities in Norway. And also we have 1 office in Svalbard, a very small island close to North Pole. And there are people working on fishing industries in Svalbard. And then we have 2 offices in UK and 1 office in Sweden, mainly working with railway transport systems and nuclear industry. And in UK, we are working mainly with oil and gas industry. In addition, we have 2 offices in Malaysia and Singapore, and 2 in Australia. So those offices mainly work with oil and gas industry. These are the service areas that we provide our services within risk management and technical safety. So 60% of the revenue comes from oil and gas industry. So there are so that's the main business area in Norway and UK. And recently we have started working with renewable energy, for example, wind, hydropower, and solar power, especially with hydrogen safety. Hydrogen safety has been a very strong focus area in recent years. In Norway, especially, we are working a lot with hydrogen safety and hydrogen production. So that's the most recent area that we have a huge focus, and it will be very important in the future. And we are also working with aquaculture, maritime, public sector. When it comes to public sector, we are working with, for example, emergency preparedness services and analysis. Recently, we performed national emergency preparedness analysis for against COVID pandemic for the Norway. In Norway. Rail transportation systems are also very important, and we are providing reliability and safety services for rail transportation and road transportation, as well as aviation. Construction and healthcare is also very important areas that we have some clients and providing. For example, healthcare sector is also very emerging business stream, and we're working with national hospitals and other important authorities when it comes to the healthcare sector, and providing, for example, emergency preparedness analysis and also some technical safety assessments for medical sector. But today in this webinar, we will only focus on oil and gas industry and safety and technical, risk analysis and technical safety. So why we need to talk about safety in offshore oil and gas industry is because we are handling flammable materials, and there's a huge potential for major accidents. So let's start with the video that shows you how severe these accidents can be. And this is a video about Piper Alpha. And I hope you can hear this.
July 6th, 19.
Can you hear the video?
Yes, Doctor. Yes, we can hear the video.
1988, 120 miles northeast of Scotland, the Piper Alpha oil rig. At 14,000 tons and 2.5 times the height of the Statue of Liberty, it is one of the largest rigs in the world.
Piper Alpha was the world's most successful oil rig. What that means was that in a single day, Piper Alpha produced more barrels of oil than any other oil rig or oil platform in the world.
A crew of 226 rotate shifts to keep the oil and gas flowing. Jeff Bollins is the chief control room operator that evening. At 9:45 p.m., Jeff suddenly hears an alarm, indicating a problem with one of the rig's condensate pumps.
Them condensate injection pumps tripped more than any other equipment we had. No panic, we knew we needed to get it back on because it was going to start affecting production.
That evening, Pump A is offline for maintenance, leaving just Pump B working. The same pump that's now been shut down by the alarm's trip system.
The condensate pumps were an integral part of the production facility. You couldn't have them both offline for any great length of time without shutting down everything.
To avoid a full shutdown, a decision is made to halt maintenance on Pump A and bring it back online. But what nobody knows is that Pump A has a fatal flaw. During maintenance, its safety valve has been removed, meaning that there is nothing to stop thousands of cubic feet of gas escaping into the atmosphere. The faulty pump is switched back on. Then, at 9:55 p.m., disaster. A spark suddenly ignites the escaping gas, and an explosion rips through the rig. Confronted by 700-degree flames, most of the 226-strong crew are now either dead or severely injured.
The nearest analogy is that it was a cross between Titanic and the Towering Inferno.
All hell was breaking loose on that rig. It was just a scene for hell. It's the only way you could describe it, a scene of absolute carnage and hell. Flames, explosions, debris. Things were escalating so fast at that point that it was almost impossible to take things in.
By 10 to midnight, less than 2 hours after the initial blast, the Piper Alpha is on the verge of collapse. Finally, the rig's legs start to give way, and the Piper Alpha starts to slide into the sea.
Where A module was and the rest of the platform just started drifting apart. And the other 3/4 of the platform just very slowly fell into the North Sea. That's my worst memory of the night, because I know for people who were still on it, it would have gone to the bottom of the sea.
A total of 167 men lost their lives that night. Just 61 survived.
That was about Piper Alpha, but I got a message that the audio quality is not still good. Can you hear me, Chanaka? Or should I change some settings again?
No, we can hear, we hear that.
But is there an echo?
No.
Okay, yeah.
No.
Yeah, so that shows you the how severe those accidents can be in offshore and oil and gas industry. But today we'll look into the basic concepts of risk analysis, technical safety, and also how we can improve the safety in offshore oil and gas industry. So this is the content for today's webinar. So we'll start with the definition of the risk. It's important to know what is risk and how we define the risk before we starting to manage the risk in offshore oil and gas industry. And then I'll talk about the risk analysis methodology that we used in offshore risk calculations. The risk analysis has two different components. We have frequency assessment and the consequence assessment. So we will look into the difference between these assessments and also how we perform these two different assessments. And also the regulations are very important. In Norway, we have very strict regulations to improve and enhance the safety of oil and gas industry. And I'll also look into the different safety regulations that we have in Norway. And as I mentioned earlier, the barrier management in operation is important, and that's the only way to ensure that that you have a safe environment to work. And we can also look into the principles of safety barrier management in operations. And finally, I'll look into we can discuss a little bit about the mysterious gas explosions in Sri Lanka. Why I call them mysterious is because there's no one responsible for the consequences and also the accidents. So that's very sad. So we will look into the gas explosions, why it occur, and how we could actually avoid them, saving some life, and also there are several people who have been injured with these gas explosions that happened recently in Sri Lanka. So if you have any questions during the presentation, so just ask me, and then we can have it as a discussion. Than just like talking and all of you are just listening. So it's important that we keep it as a discussion. So if you have any questions during the presentation, just ask me, and I can stop and we can have a discussion. So what is the risk? Risk is defined in different ways, but when it's come to the technical risk management, the risk is defined as a combination of set of consequences and corresponding probabilities or frequencies of occurrence. So that's the definition of the risk. So risk has two different elements, the frequencies and the consequences. So frequencies and consequences will define the risk level for different operations and different applications that we work with. So in oil and gas industry, we have a huge focus, or the main focus is on major accidents. So major accidents are, for example, major releases of hydrocarbons resulting fire and explosion accidents that can lead to intermediate or delayed consequences for human health, fatalities, or environmental damages, or the assets that we have in different offshore installations or in other factories or production systems. So major accidents is important, and we have experienced severe major accidents in offshore oil and gas industry, and that has given a huge focus on the improvements of safety culture, safety procedures, and design. But still, we can't avoid them because there are residual risks that these accidents can repeat again. The history, we have learned a lot about major accidents and the risk management in offshore oil and gas industry based on the accidents that has already happened. And Alexander Elshelen is one of the major offshore accidents that happened in Norway in 1980, killing 123 people. So this was their mobile semi-submersible drilling rig, and during the accident, we had 200 people on board, and normally we have accidents due to the fire and explosion in offshore installations, but this was completely different, and the platform collapsed within a few minutes, few hours, due to a fatigue failure on the one of the leg due to the sea currents and the sea waves. On that day, we had wind speed around 75 kilometers per hour and sea waves around 12 meters. So that has given a fatigue failure on one of the legs on the platform, and leading to a total collapse of the entire platform within few minutes. And we had 152 people killed during this accident. This has been a very important accident that has given lots of improvements.
Excuse me, doctor, there is a your voice is not coming properly.
Okay.
Suddenly it drops.
Can you hear it better now?
Yeah, now it's clear.
Yeah. Okay. So Alexander Elshelen is one of the major accidents that happened in Norway, and was a very important eye opener to have better safety regulations and standards when it comes to offshore oil and gas systems or production systems. Piper Alpha, we have already seen a video of Piper Alpha that was in UK sector of the Norwegian North Sea and killing 165 people. And this was also a very important accident which has changed the safety regulations in offshore oil and gas industry. As I said earlier, even though we have very strict regulations, we can't avoid these major accidents that occur in offshore oil and gas industry. In 2010, we had another major accident with the Deepwater Horizon, killing 11 people. The damage to the environment has been one of the major issue in the history. So this blowout accident has been there for like months, releasing significant amount of oil into the sea, which has been a huge issue for the coastal ecosystem in that area, Gulf of Mexico. So these are the major accidents that we have experienced, some of the major accidents that we have experienced in offshore oil and gas industry. As I mentioned earlier, those accidents has been an eye-opener to improve the safety and safety standards and procedures, but still we can't avoid those accidents because we can't avoid human errors and technical errors that can lead to these type of major accidents in oil and gas industry. So risk assessments are very important to identify and quantify the risk levels in offshore oil and gas industry. Risk analysis methodology starts with the risk analysis planning. Planning of the risk analysis can be due to many different reasons. For example, Norway has regulations to perform a risk analysis for each and every offshore installation every 5 years. If we have a risk analysis for an offshore platform, we need to update the risk analysis for every 5 years. In addition, for example, if you perform a major modification to an offshore platform, so you need to perform risk analysis. So you have to update the risk analysis that is existing for that platform. So risk analysis planning can be due to modifications, or it can be due to regulations, or if you design a new platform, we need to perform a detailed investigation of the risk from the concept phase into the as-built. So there are that's a very important part of the risk management. Risk analysis start with the system description. So it can be an operation or it can be a technical system. So for an offshore platform, in general risk analysis, we will include the helicopter transportation of personnel from onshore to offshore and back. In addition, we will include, for example, supply vessels delivering the systems to the platform, and also the risers and pipelines within the safety zone of the platform. So system description is important to specify when you perform a risk analysis for offshore platform. Hazard identification is very common systematic identification of different hazards that we have for offshore platforms. And the technology or the technique is also applied for onshore systems. It's just to identify the different hazards and threats that you can have in your system. So hazard identification for offshore platform can be a workshop where we go through all the hazards and the consequences, and also the barriers that we have for each and every hazard. The risk analysis, as I mentioned earlier, has two different parts. We have the frequency analysis and the consequence analysis. So the frequency analysis is based on the accidents statistics that we have, and the consequence analysis in modern day based on the advanced CFD calculations. So we can look into that later. Based on the frequency analysis and the consequence analysis, we will establish our risk picture. And the risk picture need to be compared with the risk tolerance criteria or risk acceptable criteria to estimate or to have evaluation of the risk picture or the risk level. So the calculated risk picture will be compared with the risk acceptance criteria to estimate or to evaluate the risk. If the risk is acceptable, and we can start working with further risk reducing measures, what we call LARP, as low as reasonable practicable. So we can perform some LARP measures if the risk is acceptable, and if the risk is not acceptable, and then we will change our system, and then we will go back to the system description and perform some changes, and then do the calculation again to establish the risk picture based on the changes in the system description or the operational procedures. The risk acceptance criteria is mainly frequency-based risk acceptance criteria that we use in Norwegian oil and gas industry, and this can be some government regulations or some company regulations that we have to follow for different operators. So this is the general risk analysis methodology that we use in offshore risk calculations. It can be different, but we will have these key elements in risk analysis calculations. When it's come to offshore risk analysis, we have different type of accidents that we need to consider. Process accidents are the main type of accident where we have risk for like fire and explosion accidents due to hydrocarbon releases. So if we have gas releases, it can ignite immediately, giving fire accidents, or it can ignite with some delay, and then we will have a gas cloud with enormous amount of energy, which can give you explosions with severe consequences. Rise accidents, we will come to that later. Rise accidents are due to leaks from subsea pipelines, and blowout accidents can occur during drilling and also during operations. So blowout accidents are very important because it can be devastating, or it can be quite severe, as we have already seen in Deepwater Horizon accident. And ship collisions are also important. As I mentioned, we have ships that comes to the platform to provide day-to-day services. And if those supply vessels collide with the platform, and it can damage the pipelines, or it can damage the structural integrity of the platform. So we have ship collision as a major element in the modern risk calculations that we perform for offshore oil and gas industry. In Norway, we also use large ships like FPSO, floating production and storage unit, or FSU, floating storage units, to handle oil and gas operations. And those ships has quite large amount of hydrocarbons, so it's important to ensure the safety on the ship, and also against the potential ship collisions that we can expect. Helicopter accidents is also important because the highest part of the risk contribution in offshore platform comes from the helicopter accidents. Helicopter accidents will include the risk during helicopter transportation, and also landing, taking off and landing operations on the platform. And also we will have shuttle tanks that gives. We get some noise from PFS Pereira. Could you please mute your microphone? So helicopter accidents is important, and it gives the highest risk contribution. Even though we have process accidents and riser hydrocarbon accidents, the highest personal risk contribution comes from helicopter accidents. In Norway, it's take approximately 1 hour helicopter flight from shore to the offshore installation. So roughly it's within 50 minutes and 1 hour. So during that time, you can have some helicopter accidents, and also most of the helicopters will have some split flights. So that means it has several landings on platforms. So you can have some accidents during helicopter landing and taking off. Occupational accidents are also important. We are having heavy lifting operations and also working, in the sea, diving, and so the occupational accidents are also important in offshore industry, in oil and gas. Extreme weather, as we discussed with Alexander L. Schillen, extreme weather is important because Norway is quite rough. The North Sea is quite rough. You will have huge waves and very high wind speed that gives you a very harsh environment or working environment. So extreme weather is very important in offshore oil and gas risk assessments. Gross error and other accidents. Gross error is also defined as a design error. Alexander L. Schillen has had a gross error in the design where it capsized due to fatigue failure. So extreme weather and gross error is important. And I have been offshore several times, but last time when I was in offshore, I had to stay there 4 days to take the helicopter back home because of the weather limitations. So if the weather is there, if you have severe weather conditions like high wind speed and high waves or sea waves, so you can't have helicopter operations on mobile offshore units, and then you have to stay several days until the weather gets settled. So it's important, and it's hard working environment if you work in offshore, especially. So these are the accident types that we have in general risk assessment in offshore platform. We also look into the different accident loads because process accidents, it's hydrocarbon accidents. It can give you smoke, heat, and explosion pressure. So when we define or when we construct an offshore platform, so we have to ensure the safety against each and every accident load. So process accident can have 3 different accident loads. We have to consider smoke from the fire when it's come to escape potential or impairment of escape ways, and both heat and smoke will contribute to the fatalities and injuries, and also loss of escape when it's come to an accident situation. Explosion is very very important, and it has the influence on the global structural integrity of the entire platform. So impact loads is related to the ship collision accidents and also the lifting accidents, and extreme weather is related to the sea currents and wind speed and other extreme weather conditions. So these are the accident loads that we consider in offshore risk assessment calculations. So the risk parameters, we express the risk both in personal as a personal risk as well as the main safety functions. When it's come to the personal risk, we have different terms. PLL, potential loss of life, and FAR is the fatal accident rate. These are the 2 main parameters that we use to express the personal risk when it's come to offshore risk assessments. So FAR value is defined as a function of the exposed hour, and it is an individual risk parameter. We also use FN curve to express the risk to the third parties. So this is very important when we work with onshore installations, where the risk exposure is not only on the first party, but also on the third party or the people living in the surrounding area. So FN curve will provide you the risk to the society or risk to the third parties around the installation. So we use FN curve, for example, to perform risk analysis for offshore pipelines, because you have ships and third party activities like trawling and fishing on the about the offshore pipelines where you have hydrocarbons. So hydrocarbon leaks from offshore pipeline can expose the ships and fishing activities, and so it's important to perform a risk analysis for those pipelines as well. So this is the personal risk parameters, but when it's come to the construction or the design of the platforms, we need to use main safety functions. So main safety functions will show you how robust is your platform design, or how robust it can, or what kind of resistance that you can have against these major accidents like fire and explosion accidents. So we have five different main safety functions. If we have an accident, we have to prevent it's getting escalated into the other areas. So in general, we define main areas, as you can see here in this platform. So this is the Johan Sverdrup P1 platform. So Johan Sverdrup is one of the largest offshore installation in the world. And I have been working with this project from 2012 until 2020, where we started the production. So this platform or the field center has 4 different platforms. We have LQ platform, that's the living quarter, and it provides you accommodation for 560 people working on these platforms. And we have production platform P1. So the production platform has separation and compression systems on the field center, and it is located approximately 100 meters from the LQ platform. So the strategy here is to prevent LQ is getting exposed to potential hydrocarbon leaks on the P1 platform. So we have 100 meters distance between the LQ and the P1 platform. And then we have a DP platform, or the drilling platform, to perform drilling operations and well intervention and well testing activities. And then we have RP platform, which is called riser platform. And across the RP platform, we have connections between the risers and other umbilicals or the power utility systems like power. So the field center is powered by onshore, so there's no power generation systems except emergency power system on the field center. So the entire field center is powered by hydroelectricity from the shore. So this is the modern technology to avoid CO2 emissions with the gas turbines and other power generation systems offshore. So as I mentioned, we have 5 different safety functions that ensure the robustness of the design. So we have to prevent escalation. So if we have a fire in the process area, we should prevent it getting into the utility area. So for example, if we have fire on the P1 platform, we should avoid it getting into the utility system on P1 platform, and also the LQ, which is located 100 meters away from the P1 platform, and prevent impairment of main load-bearing structures. That's also a main safety function. We need to avoid collapse of the platform until we have full evacuation of the personnel on board. So if we have, for example, a blowout accidents on the drilling platform, we need to have enough resistance on the main load structures, for example, jack-up and the topside construction until evacuation is completed. And then protect rooms of significance is important. Each and every platform has its own safety critical rooms. For example, communication and then control systems. So we need to prevent those rooms until we have a control on our accidents. So that means we need to ensure that all the control rooms and important safety critical rooms can function until the evacuation is performed. And we need to protect the facility's safe areas. So the safe areas are the areas where people gather in case of an accident. before the evacuations. For Johansson Field Center, we have LQ as the main safe area, but each and every platform has own safe area close to the bridge landing areas on the different platforms. So protect facility safe areas is also very important main safety functions that ensure the personal safety of the installation. Maintain at least one escape route from the every main area is also important. So that means if we have a fire on the main process area, we need to have one escape route on the neighboring area available until the evacuation is completed. So these are the 5 main safety functions that we use in offshore oil and gas risk calculations to ensure the safe or the robust design of the platform. Risk acceptance criteria is important to measure the risk level and to identify the risk reducing measures or need for the risk reducing activities. So the risk acceptance criteria are defined as individual or group risk calculate parameters, and also risk acceptance criteria are also defined for main safety functions as we have already discussed. So the main safety functions should have impairment frequency that we have to check. So if the impairment frequency is above the risk acceptance criteria, we need to ensure or we need to revisit the design and change the design so that it comes below the risk acceptance criteria. For example, if you have a higher impairment frequency for loss of escape, so you need to modify your escape routes, and you need to ensure or introduce some additional escape routes so that you have acceptable loss of escape when it's come to the main safety functions. So we have also risk acceptance criteria for environmental damage and also the damage to the third party. So here I have some examples where the risk acceptance criteria are presented. So this is the recent risk analysis that I have performed for pipeline that goes from Norway to Germany. And StatPipe is a pipeline that goes from Norway to Germany, and it transport the gas production that we have in Norway to the consumers in Germany. So this gas pipeline goes through the sea, and also there are some sections where it has some third-party exposure. So we need to perform a risk analysis and compare the risk levels against the risk acceptance criteria, as you have indicated in this figure in red color. So you can see that the risk calculation shows that the risk is above the risk acceptance criteria for certain sections of the pipeline, and based on the risk calculations, we have to perform some risk reduction measures to reduce the risk level into the acceptable area. And this is again this pipeline where it connects to the shore, and the pipeline goes from here into the terminal in Germany, and we have to assess the risk exposure if we have a leak on this plant. So you can see slightly here we have a small airport, Haugesund. So we need to calculate the risk exposure from, for example, gas leaks on this terminal, and the potential exposure on the airport, and also the houses surrounding this area. So it's important to perform risk analysis for both onshore and offshore systems, and onshore systems is even more important because then you have an exposure of the people living in the surrounding area. So risk analysis methodology need to establish based on the frequency and the consequences, and then we need to calculate the risk level and compare it with the risk acceptance criteria, and then we need to find out, okay, what are the areas that we can improve the risk by introducing risk reducing measures, and if the risk level is not acceptable, and then we need to revisit the design and then modify the design so that we improve the safety conditions in the design so that the risk level is acceptable. So risk analysis in offshore platforms start with the subsea calculations, but you have, of course, the topside leaks. And this picture here shows you a consequence of a subsea gas release. You have a drilling rig, and this is a subsea blowout. And the entire area with the white color is the area where you have a gas release from the sea. So you have a subsea release, subsea blowout, and it comes to the sea, and then it releases to the atmosphere. And you can see that there is a ship here. And so if we have a ship that goes nearby or across the this gas cloud, it can get ignited because you have several ignition sources on the ship. And in addition, if we have a similar, if we have this kind of gas release and it comes to the top side of the platform, and on the top side of the platform, you have several generators, several ignition sources, and then it can easily get ignited, and you can get consequences like Piper alpha. So this kind of gas releases can occur due to drilling operations, or it can be due to failures in flow lines and subsea equipments, and naturally it can occur due to slippage from the ocean floor. So this is not that dangerous because it's spread over a large area. But when it's come to point releases like drilling blowouts and subsea flow lines, and that can give you quite dangerous situations because of the high gas concentrations and ignition sources that can have on topside process platforms, or for example ships that cross those gas releases. And this kind of gas releases are quite hazardous because it can give you fire and gas explosions. And also if you have a ship that crosses these gas leaks, or the areas with gas leaks, and it has the quite significant change in the buoyancy force, and that can give you accidents like, for example, capsizing of large ships. And also environmental impacts are important, like Deepwater Horizon, and the blowout has been there for like several months, and that can be quite dangerous to the ecosystem that we have in the sea and also on the coastal area. In Norway, in 2004 has been a very bad year. We have experienced 3 different subsea gas releases, but fortunately, none of them got ignited. So Snorre Al, I have been there on this platform, and it has the subsea gas blowout in 2004, and we have detected gas on the top side. But luckily, the wind direction was on the favorable side, so the wind has taken away the gas cloud that comes to the platform. So if it was ignited in 2004, at that time we had 168 people on board, so it could have been a disaster like Piper alpha. But luckily, the wind saved all the people working on the platform, and it was quite lucky to have the wind on the favorable direction, where it took or away from the living quarter where people are accommodated. So in 2004, we had several subsea releases, and then the Norwegian government has introduced several strict regulations to prevent subsea gas releases, and also to assess the risk levels from those releases. So this is a video from one of my simulations that I did in 2011, I guess. So this shows you typical subsea release, and how it can expose a exposed platform. So this is a release with 440 kilos per second gas release, and you can see that it can damage the entire platform. And for example, helideck will not be available, and the lifeboats will not be available because you can't launch lifeboats to a fire. And so people on the platform will be restricted to the living quarter, but there is a huge potential for killing most of the people if we have this kind of severe accident on offshore platform. So subsea gas releases and how we model them is very important when it's come to the risk analysis of the offshore platforms. So consequence modeling is normally done with the safety softwares. So we have different softwares for modeling fire and explosion accidents. You can see some of the simulation results here. So this shows you the wind field around the platform. So this is important to investigate the working conditions against the very cold environment in North Sea. So you have to perform like wind chill analysis and working environment analysis based on the CFD calculations. And these are the consequences of fire calculations. As you can see here, we need to perform these calculations to evaluate the loss of escape and also the structural integrity of the offshore installations. And this is, I think maybe you have heard about this accident in England, Brownsville accident. So it was in 2005, and Brownsville is one of the very large oil storage facility in UK. They have had an explosion accident close to one of the tank, and it was escalated into I think 28 tanks on the facility, and it has been quite severe accident. But luckily, no one was killed, but around 40 people were injured due to these accidents. So several institutions have performed investigations on this accident. And it has been quite important to, for example, include all the trees at the fence of the installation to predict the realistic explosion loads that they have experienced. So the accident has been quite significant, and it has damaged, for example, vehicles which are parked in the neighboring parking areas, and to model the explosion pressure on these vehicles. So you had to include all the trees and the obstacles surrounding the facility. So in this case, you have experienced the detonation. So you have explosion waves which are traveling quite fast, and to model the consequences that they have observed on the vehicles and surrounding area, you have to include, for example, even the minor objects like trees and the objects that you have with the pipelines and other constructions in the facility. So consequence modeling is very important. Very important when it's come to the offshore risk assessments. So based on the frequency and the consequences, so you can establish the risk picture, and this is a typical risk calculation or risk results that you can find in offshore risk analysis assessment, risk assessment. So this shows you the presentation of the personal risk. Again, this is for the Johannes Group Field Center. You have a production platform with the highest risk level, and the living platform with the lowest risk level. So the drilling platform has a medium, or it has a certain risk because of the blowout accidents. But the RISE platform, we have a modern design with the subsea isolation valve, which limit the duration of subsea leaks. So you have we have a lower risk level on the RISE platform on our Group Field Center. So living quarter, as I mentioned earlier, so it's 100 meters between the living quarter and the production platforms. That gives you a safe working environment. So the risk level at the living quarter is very low. But the acceptance criteria for the offshore platform when it's come to the personal risk is 10. For the Johansson group, we have calculated it to be 2.3, so which is well below the acceptance criteria that we have for offshore installations. But to make it more sense, we need to compare this with the real-time experience or the day-to-day activities that we do. So if you drive a car in Norway, you have a FAR value of 18. But I'm sure that if you drive a car in Sri Lanka, this can be quite high because of all the accidents that we observe in Sri Lanka due to poor traffic and road rules that we follow in Sri Lanka. But if you drive a car in Norway, you have a FAR value of 18, and this shows you that it's much safer to work in offshore compared to driving a car on the street. So that means we have quite strict safety regulations in offshore to prevent major accidents and the impact on the personal safety and also the environment. So it's important to follow all the safety procedures and the standards to minimize the risk level in offshore installations. So I mentioned earlier that we need to use the main safety functions to ensure the design or to evaluate the design of the offshore platforms. So this is the presentation of the impairment of main safety functions. And you can see that all the main safety functions or the impairment of main safety functions are well below the risk acceptance criteria. And we need to present these results to the government to accept the construction of these platforms. So based on the analysis that we perform, the government take the decision to accept the construction of the platform. So it's quite important that we perform a detailed investigation based on the consequences and also the frequencies that we accept for these type of accidents. So the frequency calculations are mainly based on the historical data. So we will analyze the historical data for leaks, for example, subsea leaks and topside leaks, and then we use the consequence calculations to establish the risk picture. So the risk acceptance criteria are stipulated by the government, and also we have risk acceptance criteria which are applicable for different companies. So when the risk is calculated and when it's compared with the risk tolerance criteria, so we can take precautions, or we can improve this design by taking alarm measurements, or when we have a risk in tolerance area or tolerable risk, can further reduce by taking risk reducing measures. And if the risk is intolerable, the design will not be approved, and then we need to do some design changes to minimize the risk level. So when it's come to designing of an offshore platform, so we need to consider 3 different major elements. We need to eliminate the risk if possible. For example, if you have a chemical that gives you the same functionality, but one is hazardous, the other one is non-hazardous, so we need to select non-hazardous chemical. So that's the way of eliminating the risk. And they reduce the probability of the undesired event, and that's kind of like a proactive. So we need to reduce the risk of the accident. And then we have reactive measures, like if we have an accident, and then we need to reduce the consequences. So, for example, designing a better escape ways and designing a better emergency preparedness system, so that can reduce the consequence of a given accident. And so the residual risk So when we have tolerable risk, we use alarm measures to reduce the risk, and the residual risk need to be handled with procedures, training, and emergency preparedness system to manage the consequences that we have from an accident. So when it's come to the regulatory or the standards, Norway has been quite clever to stipulate the regulations to ensure the safety of offshore oil and gas industry. So there are very few accidents that has been occurred in Norway compared to the other areas of the world. For example, hydrocarbon leaks that we have experienced in Norwegian part of the North Sea is much lower compared to the British sector on the North Sea. So Norway has been quite clever to have very strict regulations when it's come to the offshore operations. So these are the summary of all the regulations. I will not use time to go through each and every regulation here, but we have two set of major regulations for framework regulations and management regulations. And then we have facilities regulations, which gives you the guidelines for designing different operation platforms. And then we have activities activities regulations and technical and operational regulations. So these are the main regulations, and we also follow the international regulations. And we have NOSOC, which is Norway specific regulations, so it's regulations that we have to follow in Norway. So these are the main regulations. And if you go into the Petroleum Safety Authority in Norway, so you can read about all these regulations that we have, or that is applicable for Norwegian oil and gas industry. So this is very important, and it is quite clear and very informative, and gives a very good set of standards and regulations for risk analysis calculations, as well as for the design and operation of the offshore platforms and installations in Norway. So once you have the risk picture, and when the design is done, but you need to have you need to follow the sound operational procedures to minimize the accidents. So in this picture, there's a girl filling the car with benzene, but at the same time she's smoking. So this is quite dangerous, because you have an ignition source with you, and also the flammable material. So if there is a leak, and then it will ignite, and it can be quite dangerous for you, as well as for the person in the surrounding area. So therefore, you need to consider the operational elements of the barrier management or the safety, in addition to the technical design. So when it's come to the operational barrier management, or the barrier management in general, you have three different types of barriers that you can control and focus. So you have technical barriers. Technical barriers are coupled with the design of the platform, and then we have operational and then organizational barriers. So organizational barriers are related to the policies and the higher level of operation. And when it's come to the day-to-day operation and the design, so we need to follow the operational and technical barriers. So barrier management is important, and you need to use the risk calculations and the safety strategy to define the performance standards for different barriers that you have. For example, you need to have functional requirements for gas detectors and fire detectors, and you have to have reliability. The safety critical system should be reliable, and for example, isolation valves should have a very high criticality level to ensure that it will function in case of accidents. So there are different type of safety integrity level, what we call SIL levels, for safety components that we use in offshore oil and gas industry. So technical safety design and the operational barrier management is important. And normally we use a bow tie model to identify the different barriers and the threats that we have. So bow tie diagram will combine the threats and the consequences, and also it will illustrate all the barriers that we have to prevent and limit the consequences. So engineering barriers or the technical barriers, and then we have organizational barriers and human or the operational barriers. So these are the three different types of barriers that we have to prevent accidents happening. And if the accident occurs, and then we have a certain set of barriers that will prevent the consequences. Again, we can have engineering, organizational, and human barriers to prevent the consequences. So this is a very simple illustration of a bow tie model, and bow tie models are important to visualize the available barriers, and also it will combine with the maintenance procedures that we have offshore, and also this is applicable for onshore. So it will combine with the inspection and the maintenance programs to ensure the safety of the plant operation. So these are the key elements when it's come to the process safety. So you need to follow the regulations when you design plants, and especially from the concept to the final construction, you have to have safety as a major, as a very important part in the design. So I got a chance to read the tender document for the new refinery construction in Sri Lanka, and the entire documentation was some 100 pages, but I couldn't find any sentence regarding the safety of the new design. So I was really surprised why we haven't focused on, for example, safety in new refinery project that we have in Sri Lanka. But in Norway, safety comes first in all the new projects and all the modifications, and every project that we work, we have to ensure that safety has been taken into account from the concept into the final design. So it's important that we have a focus on the safety from the concept phase, because it will be quite costly to introduce the safety precautions when the design is matured. So it's important that you consider the safety from the concept into the final design. Risk analysis and procedures are also important. You need to have training and organizational barriers to control, and the process control, alarm management, inspection, testing, maintenance of equipment are very important. So we use the Swiss cheese model to identify the barriers and the weaknesses of the barriers in general. And so we need to perform audits and testing of the different elements and the barriers to ensure that it will function in case of an accident. So at the end of the presentation, I will focus on the management of change. This is very important, and this is the key element that fails during the recent mysterious gas explosion accidents in Sri Lanka. So last couple of months, we have experienced several gas accidents, and people are talking about different reasons like gas cylinder puranne sanite venaskerimen, but people are talking about some other reasons, like, for example, these gas releases are due to the failures in the regulators and failures in cylinder valves. But there are a lot of arguments and discussions around this in last couple of months in Sri Lanka. But actually, why these gas explosions occurred in Sri Lanka? So I will use some time now to present my understanding of the problem and how we could avoid this, how we could have been avoid this in the saving some life and people getting injured. So I have heard that there are some fatalities or some fatal accidents has occurred, and also people have been injured due to these accidents, and it has been quite unrest in the society. So this is actually related to the last part of the last element in this key element in the process safety: management of change. Why is related to the management of change? It's because we had several discussions, but the two main gas suppliers, Litro and Love Gas, they came with this explanation for the whole incident. Explosions have occurred mainly due to the leakage from fault regulators and from the connecting hoses from the gas cylinder to the cooker, but not cylinder itself. So this was the explanation from the Litro and the Love. And it's very sad to see that they haven't focused on the safety of the people and the consumers, that gas consumers that are very important for their business. So so this was the conclusion from the companies, but they haven't forgot, they haven't thought about actually the pressure in the gas cylinder and the composition in the gas cylinder is also important for the operation of the, for example, the connecting hose and the regulator and the cylinder valve, and also the cooker at the end. So if you have a higher pressure in the cylinder, that of course will influence the reliability and the performance of the other equipments which are connected to the gas cylinder. So this was very sad, but this is what happened in Sri Lanka. So before we start, what is liquefied natural gas, or what is liquefied petroleum gas? So LPG is the energy carrier which derives from the crude oil refinery or natural gas processing. So it's extensively used for domestic applications and also for industrial applications. So LPG contains mainly propane and C3H8 and the butane. It can also contain small portions of propylene, methane, pentane, and other minor constituents from the natural gas production. So these hydrocarbon gases does not have any odor or smell. So we need to have a methyl mercaptan to provide indication of the potential gas leaks. So this figure here will show you the main physical properties of butane and propane. That's quite important to understand the problem. So I heard that they had some marketing campaigns from the Love and the Litro when they introduced new gas composition, and they were telling that it will be easier to cook and it will be faster to cook, and it's because of the energy content, and the energy content of the new composition that they had was had more energy and higher flame temperature compared to the previous composition that they have. And so if you see the boiling temperature of these two gases, propane has a very low boiling temperature compared to the butane. So in Sri Lanka, for example, with average temperature above 30 degrees, so we used to have higher concentration of butane and lower concentration of propane. But in colder countries, like for example, Norway, we could have more propane in our LP gas because of the cold temperature conditions. But in Sri Lanka, we used to have a high propane content in the high butane content in the gas that we use in day-to-day applications. When it's come to the gravity or the weight or the weight of the gas, so we have a light. Propane has a slightly lower density compared to the butane, but both of these gases are heavier than air. So that means it will accumulate at the floor or at the ground if there is a leak. So that's quite dangerous, because if we have a leak in the night, so it can accumulate on the floor or close to the floor, and if there is a ignition source, it can explode in the morning. So that's what happened in most of the cases in Sri Lanka. So size and the pressure of gas cylinders. Domestic gas cylinder is a pressure vessel. So you have to, or there are strict regulations or strict standards in designing domestic gas cylinders. So in general, we have pressure around 3.6 bar in a domestic gas cylinder, and it can be different if you increase the temperature, of course. But it is a pressure vessel and it has own design specifications because it's it contains a significant amount of energy at high pressure. So the pressure inside the LPG cylinder is equal to the vapor pressure of the vapor pressure, because you have a mixture of propane and butane, and there is a liquid and gas phases. So there's an equilibrium between liquid and gas phases. The pressure inside the tank is actually the equilibrium pressure at that temperature and the pressure at that temperature. So vapor pressure is, of course, depend on the temperature and also the mixture of the hydrocarbons. In Sri Lanka, we used to have a mixture of 80%. Sorry, I think it should be opposite. 80% of butane and 20% of methane, and the pressure can be as high as 16 bar if you increase the temperature to 65 degrees. So so this figure here shows you the entire story, what happened in Sri Lanka. We had 80% butane and 20% propane, and which gives you the vapor pressure of 53.6. So that is around 3.6 bar. But the suppliers or the Litro and Loft Gas, they changed the composition to 50-50, and that gives you 89.4 vapor pressure, which is approximately 8.6 bar. So the pressure is almost doubled from 53 psi to 89.4. This was done mainly because of the financial reasons. The cost of the high propane gas is cheaper compared to the gas composition that we had for a long time. So all the gas cylinders, all the appliances that we had, and the cookers and the pipelines and the fittings were designed for this pressure, which is 3.6 bar. And suddenly these two companies, they have changed the composition to 50-50, which gives you 8.6 bar. So the gas cylinder itself has been designed, or it is designed for high pressure conditions. So that's no problem. But all the other appliances, I mean the valves, regulators, hoses, and cooker, so they are designed for this pressure, which is significantly lower than the new pressure that they have with the higher concentration of propane. So that's what happened, and it gives a lot of leak sources, because this is the normal sketch of the gas fired cooking stove. So we have gas cylinder, and then we have a cylinder valve and the regulator, and the regulator is connected to a rubber hose, and it is connected to the stove. So if we have 8.6 bar instead of 3.6 bar, and of course that will increase the potential for the leaks in the downstream systems. Or you don't have leaks from the cylinder itself, so that's obvious, because the cylinder has been designed for higher pressure conditions. But the regulator and the cylinder valve and the hose and the cooker is designed for 3.6 bar. So when the pressure is increased, there is the potential for the leak sources, and these are the most likely leak areas. You have a screw which is connected to the cylinder, and also you have several leak sources. So if you have a higher pressure in the cylinder, and that leads to a leak of the gas, and gas is heavier than air, and it accumulates, and it will not disperse in the air, and it will accumulate over the night, for example, and in the morning. So if you fire a fire stick or switch on like switch on a light and with a spark, and that gives you the ignition, so it will be an explosion. So this is what happened. And so there has been a lot of news and paper articles about how we will discover or how we will identify the leaks. And there has been severe accidents, and yeah, it has been lots of discussions about this. But this is purely negligence and improper safety management systems from the companies and also from the government when it's come to the regulations, because the companies can't do the changes to gas concentrations and sensitive technical information which can influence the general public. So we need to have proper standards from the government, and the companies should also be responsible for what they're doing. And this accident could avoid by doing a proper study about this management of change. So if they are planning to do a change in the composition, a proper investigation should have been done to analyze the consequences of the high pressure and what will happen when we increase the pressure from 3.6 to 8.6 bar, and how will it influence on the regulator, and how will it influence on the rubber hose and also the cooking appliances. So this has not been done, and the consequences have been several fatalities and hundreds of injuries, and also poor people, they have lost their houses, and I'm not sure whether they have done proper compensation for the accidents that happened due to the gas releases and explosions in Sri Lanka. So this was very sad story, and they haven't focused on this at all. And the companies, they haven't done anything, and they just pass the ball, saying that all the gas explosions is not the tank itself, and it is the regulators and the valves. Why the valves and regulators leaks is because of the high pressure, and the high pressure is because of the change in the composition. So this is a chain of events, but they just pass the ball to the suppliers of the valves and the rubber hoses and the cookers. But this is just negligence from the gas suppliers and the government. So I haven't got chance to read the expert committee documentation, but on the internet they have presented some recommendations, and those are the recommendations. There were like 11 recommendations to ensure the gas cylinder purchase has no leaks at the point of purchase. So this is very difficult to assess, because then you need to use the soapy water test at the purchase point, and that's not practical. A gas leak need to be reported to the local police and its investigating committee by calling these numbers. Again, the gas leaks will be dangerous, and it will lead to an accident before you report. To refrain from using various methods that are not scientifically proven, and general public, they don't have a very good understanding about the scientific and non-scientific methods and leak detection system. So this is not a very good solution, and leak must only be tested by experts recognized committee. That's too late if you have a leak, and that can be dangerous. So of course it's nice to have recognized and experts to check the leaks, but this is not a sustainable and very wise solution, as I understand. No gas cylinders exploded in the recent explosions. Of course, the gas cylinders are designed to have a higher pressure than the fittings and the regulator valves, so that no gas cylinders have been exploded. To ensure regulators is not of inferior quality, regulators and other appliances have been designed for previous pressure conditions like 3.6 bar. So it's not a very good solution to change the fittings and the regulators, because that can be dangerous. To ensure the regulators come under the Sri Lankan standards. But as you can see here, there's no recommendations or guidelines for the companies when they change the compositions and other sensitive parameters. So in my understanding, we need to have very strict regulations for the suppliers when it's come to the gas composition and also the percentage of mercaptan, ethyl mercaptans that we have to identify gas releases. So those recommendations I couldn't find actually. Maybe they are introduced in the government regulations, but it was not in the expert committee at least. So this is what we experience due to pure negligence and poor safety management systems in Sri Lanka. So this is actually what I have, but I didn't get any questions. I hope you have some questions before we conclude the session.
Yes, thank you very much, Dr. Amarnath. So, I think audience, you can ask your questions. You can raise your hand and then, okay. Engineer Vedita is raising hand. Please,
Yeah.
Please proceed, Engineer Vedita.
Dr. Amarnath, good evening, everybody. Thank you very much for that excellent presentation. Just to add something, in Sri Lanka, we don't have major accident hazard regulations. So, in fact, we are zero there. We are lacking in that particular area. Process safety, in fact, is not addressed sufficiently in Sri Lanka. And I'm happy to see Dr. Amarnath really present something of substance. What I would like to ask Dr. Amarnath is what sort of knowledge transfer can you do if, let's say, University of Moratuwa or
Hello, I missed the sound, Chanika.
Yeah, Engineer Vedita, we can't hear you. Maybe he's on mobile. I think his question is how you can support for a combined effort to establish all these things. Shall we wait till Vedita returns?
Yeah.
Yeah.
Yes, Vedita. Now we can hear you again.
Yeah, my question is actually how can you support Sri Lanka to develop the technical know-how and the competence, because we are right now lacking. We are at zero. We have done some work. There are some genuine QRAs being done in the petroleum industry, in the offshore sector as well as in the onshore sector. But as far as competence is concerned, we are lacking, and we really need the support. Thank you.
Yeah, that's why I said, because I got chance to read the this tender for the new refinery development in Sri Lanka. I couldn't find any sentence about the safety and how we manage the safety, and there was nothing regarding the safety when they call for the tenders for the construction of the new refinery. So we need to have proper regulations in Sri Lanka, and we are talking about offshore oil and gas production in Sri Lanka. So this is a very important area, not only for the offshore oil and gas industry, but also for other onshore oil and gas handling systems like a refinery that we have, and LPG handling systems. So we need to have proper standards regarding the major accidents and how we handle the major accidents. So there are a lot that we can learn from Norway, and I have been working with offshore oil and gas for almost over 12 years, and so there's a potential for knowledge transfer, and not only me, and there are several other colleagues that have been working with the offshore oil and gas industry in Norway and globally. So we are ready to transfer the knowledge, and we are ready to share our knowledge with you guys. But we need to establish a forum and do it properly. But yeah, if you can initiate for example, program or presentation. So then we can contribute with our knowledge and discuss how we can improve it in Sri Lanka. So this should also come with the government and the Ministry of Petroleum. So they have to think about it in the future and make regulations and guidelines for establishing requirements for risk analysis and the guidelines and other information. Of course, we are happy to help, but we need to have a proper program for it.
Thank you very much. Most welcome.
Yeah, but do we have any cooperation, or do you have any cooperation with the University of Moratua or the ministry?
No, we don't have any. I will just briefly explain how the petroleum industry in Sri Lanka goes about with the process safety management system. I mean, it's sort of like there is no central regulation. If you take, for example, a company like Chevron Lubricants, Caltex, they have a very well established system because that is run by corporate Chevron corporate in USA.
Yeah.
But if you take the local party, let's say we are doing an LNG project in Sri Lanka, of course, we have brought in the QRA requirement into our tenders. So that is there. But this is not there as a standard requirement. There's no standard regulations in Sri Lanka. And in fact, it depends on the operator to set the QRA risk acceptance at ALAP and then float the tender. So it's not a standard practice. That is where the issue is.
Yeah, of course, like ExxonMobil and Holy Parsons or like Shell, they have their regulations with respect to where they operate. So there's a company regulations that they need to follow. But the important thing in Norway is that we have Norwegian standards. Like we have standards that are established by the Norwegian government. So the companies that are operating in Norwegian or North Sea should also follow the government standards in addition to their own standards. So it's very important that government comes with regulations and procedures when it's come to handling flammable and hazardous materials. So we can learn a lot from the global operators, but we have to also establish our own regulations and guidelines when it's come to oil and gas industry and other industries handling hazardous chemicals and materials. So as I said, so we are flexible and we can contribute with our knowledge. So we need to establish a knowledge transfer system. This is a very good forum, like to present at IESL webinars, but we can maybe arrange some physical seminar or some other programs to do it more effectively in the future.
Thank you very much. Your offer, I think, will be most welcome. Thank you.
Yeah.
Yeah. Thank you, Engineer Vedita. There are a few more hand raises. I think Engineer Kodagoda is there. Yeah, Mahesh is there. Yes.
Yeah.
Yes, Mahesh.
Hello, sir. Can you hear me?
Yes, I can hear you.
Yeah. So first of all, thank you very much for your nice presentation. So because this is a very timely requirement, because Sri Lanka at the moment introducing natural gas for the power generation in a larger scale. So I'm asking, my first question is, what do you think about using natural gas compared to the heavy fuel oil or diesel for large scale power generation? My second point is, now Sri Lanka is planning just to establish FSRU in off Keravalapitia, and they are planning to supply natural gas to Yugadalavi. So I'm asking, what are the critical risk factors when stationing FSRU and pump that natural gas directly to the Yugadalavi compared to other methods?
Yeah, do we have gas power plants in Sri Lanka now? As far as I know, there's no.
Yeah, no, Sri Lanka, Yugadanavi and Sobadanavi to be commenced in 2023. Yugadanavi both are combined cycle power plants. Now Yugadanavi is running at heavy fuel diesel, but it can be converted to natural gas. That is what Sri Lanka is planning to do. Sobadana we definitely same combined cycle. So
But
both power plants can be driven by natural gas.
Yeah, what's the source of natural gas that they're planning? Is just the import gas?
I hope you heard this a really interesting topic. Sri Lanka New Fortress Energy USA.
Yeah.
So they are trying to supply natural gas to these two power plants through FSRU.
Okay. Yeah.
That ship, a floating storage and regasification in off Kerala PTA. So I'm asking what are the critical risk factors, because you discussed about offshore platforms, but this is not just a platform, it is just like a ship stored with natural gas, 170,000 cubic meter. So I'm asking what are the critical risk factors in terms of FSRU?
Yeah. In Norway, we don't have any gas power plants. So 100% of the electricity consumption in Norway is provided with the hydropower plants. And that's very good. But in Sri Lanka, we have a lot of uncertainty regarding the hydropower plants. So it's important that we have some other systems. Like when it's come to the risk factors, handling of liquid fuels and gas fuels, it's different. Like diesel, if you have a diesel transport system and diesel power plants, and the risk level is much lower compared to the, for example, gas power plants, because if you have a gas power plant, there's a risk of flammable gas clouds and the leaks compared to the diesel power plants. And so the risk level is completely different. So you need to perform a very good risk assessment before actually the conversion is before we convert it to the gas system. Because if the system is designed for liquid, you mentioned that is a combined system, so it can be operated in gas mode. But the risk level is completely different, and you need to perform different risk assessment, and you need the leak frequencies and the consequence will be very, very different. So you have to perform detailed investigation of the risk level before the actual conversion is done. I'm not really sure whether it's planned or whether there's a requirement of doing it. I'm not really sure, but so this is a very, very important aspect that you have to consider, because the risk picture is very different compared to diesel operation and operation with the natural gas, for example.
So shall I ask one question? Another question?
Yeah, of course,
Yeah, sir, when FSRU is stationed, because FSRU basically, you know that around 20 megawatt power plant is working continuously for regasification of LNG into NG. So when it is in offshore area, due to the operation of these power generators, are there any impacts to the marine ecological creatures, just like flora and fauna? Do we need to do any noise impact assessment to assess the impact to the marine flora and fauna? Is it necessary?
I'm not 100% sure, because I don't have a very good experience with the environmental risk assessment, but there are I think it's important to consider those aspects, and there are regulations covering those environmental aspects. So in my experience, I haven't, or in my current work, I haven't worked with environmental risk assessment. So so then you have to consider actually the regulation relating to the environmental risk assessment. Maybe I can find the Norwegian requirements that we have and share it with Chanaka so that you can get it from him.
Okay, sir. Thank you.
Yes, we have Tista.
Yeah, I'm Tisali again. Now, with respect to the safety regulations, what is the regulatory authority in Norway? What type of regulatory authority? I think, to my knowledge, there is no regulatory authority in Sri Lanka for safety regulations. So, what is the regulatory authority in Norway?
We have two different regulatory authorities. Like, for example, when it's come to oil and gas, so we have Norwegian, or PSA, Petroleum Safety Authority. In Norwegian, we call it Petrol or Petroleum Tilsynet. So Petroleum Safety Authority has responsibilities for offshore platforms, like handling of hydrocarbons in offshore. That covers like fixed platforms and mobile offshore unit, and for example, FPSO and storage unit like shuttle tanks. So all the offshore activities are governed by the Petroleum Safety Authority, and they have standards and regulations for each and every activity and operation and design. And also, Petroleum Safety Authority will cover the operation of the onshore terminals. Like we have refineries that process hydrocarbons and export to, for example, Europe through the gas pipelines that we have. So the Petroleum Safety Authority in Norway has the responsibility for offshore oil and gas, and also the terminals or the onshore terminals that we have. When it's come to onshore installations like onshore chemical plants and hydrocarbon handling plants, and we have DSB, and that's another authority that governs or have regulations for onshore plants. As you said, I also know that there are no standards or regulations and authorities for working on these things in Sri Lanka. So there's a huge room for improvements when it's come to the safety regulation and standards in Sri Lanka. So there are separate governing bodies in Norway to handle offshore and onshore facilities when it's come to hazardous material handling.
Yeah, what do you suggest now for Sri Lanka? Like now, I know, for example, in India, there is a authority called Petroleum and Explosives Department of India. So like that take care of, I think even pressure vessels also taken care of by that authority, the department, like even cylinders when it comes to pressure vessels, cylinders and various other things. Is regulated by Petroleum and Explosives Department of India. So for Sri Lanka, to my knowledge, there is no such department or authority. So what do you suggest for Sri Lanka? What type of authority?
Yeah, for example, like pressure vessels, and then we have international standards like API 570 boiler and pressure vessel design. There are lots of international standards. There are a lot of operators that have very strict and good recommendations and guidelines. But it's a responsibility for the government. Like, for example, Ministry of Petroleum Ministry should have task force for establishing these guidelines in Sri Lanka. But I'm not really sure how or where we are with this petroleum exploration. It's quite interesting to mention that the petroleum explorations in Sri Lanka has been started in 1965, as I remember, and in Norway we have started in 1969, and the first well was discovered in 1969 in Norway, and we have started production from 1970 in Norway, while in Sri Lanka we are still exploring oil over 40 years now. So I'm not really sure where we are now, but before we start the production or the construction of offshore installations in Sri Lanka, it's extremely important that the government will establish the guidelines. Like as we have mentioned in in India, we have certain authorities and guidelines for following these activities, because it's quite hazardous and the damage can be very significant. So the ministry and the government should actually have a task force for establishing these guidelines, and they can of course contact us because we have been working in the field for many years now, and even there are some people with even more experience in Norway as well as in other parts of the world who can contribute and who are willing to contribute for the country and establishing these guidelines that we need in Sri Lanka. So it's important that government think about it and have a task force for doing it. Otherwise, it will be very difficult. in the future.
Thank you very much, Dr. Amarnath.
And we have Sumudu.
Hello.
Yeah.
Yeah. First of all, thank you, Dr. Amarnath, for conducting this really valuable session. And I have two questions actually, which I have mentioned over the chat box also. Let me summarize because the time being. First is we do have a very old refinery in Sri Lanka, and we also know that it emits sulfur because there is no sulfur capturing, and that is a really big hazardous. But apart from that, now because of its old nature, what is your opinion about like having you have shown really big disasters happening in the offshore oil or the gas these terminals, but what do you think about this refinery? How it will be if something like that happen? Because as you can see, Sri Lanka does not have any proper governing authority for such kind of things, and also the gas explosion, no one take the responsibility. And for example, Sapukaskanda, this refinery area, there are a lot of population surrounding that. How bad it could be for them? If there's any, do you know any such modeling has been done for such that refinery, if that going to be exploded or something like that happen? Because I do not have such idea about that one. That is the first question. The second question is about like Mr. Tissa said, about having a single kind of authority, which is an independent one, who could investigate and make recommendation instead of haphazard committees, as you have shown. They do not have clear idea what they are doing, and if we have an independent body responsible for, like let's say for the parliament or the president kind of things, like I have a little bit look into that one, and I found that Chemical Safety Bureau, which is in USA and in Canada, that has some sort of authority to investigate such accidents. Because when it happened, like a few months ago, it happened in the gas explosion, and beforehand that we had like a sea disaster. The ship fell in a nitric acid explosion, and that thing, and then after that we had like the ammonia accidents in Sri Lanka, in some factories. But all these things are handled by different authorities, and finally what happened, none of things were taken seriously. No lessons learned from this accident to prevent happening it in future. Those kind of things, how we could avoid, and what is your opinion on that one? That is the second question. And thank you again for your valuable time and sharing your knowledge with us. Thank you.
Thank you very much for the question. And can you see the screen now? Can you see what I'm sharing?
No, doctor. Still we can't see.
Okay, now you can see, right?
Yeah, it's coming up. Yes.
Yeah. So this is a similar accident. So this was the Broomfield accident in UK. So one of the largest hydrocarbon storage facility in UK, and it was also located in a very congested area. And the accident has been quite devastating. And they have experienced, for example, detonation or the explosions with detonative gas or the pressure waves. So it's quite important. Like in Norway, we have safety requirements or regulations. I can also show you a bit about it in the presentations. Yeah, this figure here. So in Norway, we have regulations like, for example, if you have a hydrocarbon facility and the safety contours, like for example 10 to the power minus 7. So that's the frequency of fatality. So if you need to establish the risk contours based on the risk calculations, and it's not allowed to have any houses or any public places within 10 to the power minus 7 area, or within the 10 to the power minus 7 risk contour. And if this is applicable, if this is applied in, for example, Sapagaskanda, that will be a disaster, because I think they are handling quite large number of hydrocarbon inventories, and if it is ignited or if it's an accident, and that can be quite dangerous, and it can expose the surrounding area. And I'm not really sure whether they have those regulations, but I guess it's not there. But in Norway, we have very strict regulations. For example, planning the land and construction. So if there is a facility that handles the hazardous material, and then you have very strict regulations for land usage around that facility. So it's not allowed to build or use the land within 10 to the power minus 7 risk contour. That's the fatality risk contour. So it's important to establish a QRA, or to perform a QRA, to calculate and establish these risk numbers to get an idea about the risk level for the surrounding people. So that's the question number one. But the question number two is the regular, again, the authorities like Chemical Investigation Bureau in the USA. They have they have done a lot of very nice investigations, and you can find a lot of their videos on YouTube. That actually gives you very good understanding about the risk and the consequences, and the contributing factors for those risk levels or accidents that you have experienced. But in Sri Lanka, unfortunately, our politicians they have wrong focus and strategies. So they have to establish authorities and the governing bodies for establishing the guidelines and investigations, and documentation of these accidents is very important. That's the only way of learning things. Like, for example, this recent gas accidents, and as I mentioned, it's mysterious accidents because no one is responsible, no one is taking the responsibility for the consequences, and some people they have been killed, and some people they have been severely injured, but no one is caring of those accidents or injured people or the fatalities. So it's a very sad situation, but we need to focus on it in the future, and the government has to establish the authorities and standards covering these areas as soon as possible, because that can be quite dangerous if we experience those accidents. For example, like Bruins Feed. So if that repeat in Sapagaskanda, and that can be very, very dangerous. Do we have questions?
Dr. Amaranath?
Yeah.
Yeah, I'm Kodagoda.
Yes.
Presently working for petroleum industry in Sri Lanka, right?
Yes, I know you.
Yeah, I know you too. We had several sessions earlier, right?
Yeah.
Okay. Okay, and regarding the petroleum sector in Sri Lanka, people ask questions, especially on Sapagaskanda refinery and the expansion as well. Luckily, I got the chance at the end to talk with you on this Sapagaskanda refinery. Say, as I am working in the refinery, I know that we are following international standards in the refinery. For construction, STM, API, and NFPA guidelines. and we follow those things within the refinery. And regarding our expansion project, right, we have done, we have gone just up to techno-economic feasibility of the project. That's all we have gone now. Up to now, we haven't go for any tendering process or any RFP stage. It's supposed to go, right? And also regarding the incidents happened within the refinery, we had a fatal accident in the refinery in 2012, and we had like investigation related to that incident, which was done by the government, and we had several learning points from that incident, and we did a significant amount of improvements in our procedures and those things to avoid such a thing happening again in the refinery. And say someone may tell that we are not learning from any incidents in Sri Lanka, but we know that as actually working in the industry, we know that we have learned from things, and we have taken several steps to improve the things to avoid such a thing happening again, uh, again. Especially related to petroleum industry, we have done those things, but those things may be not published as in other countries. Maybe we have done several things internally to avoid such a things happening again and again. Especially regarding the expansion of the refinery at Sapugaskanda. We have studied the land requirement, and we have done this feasibility through an internationally reputed organization, that is KBC Advanced Technologies Singapore.
In Singapore.
Yeah, and they have demarcated the required land areas with safety buffer zones for the expansion. And say now we are in the stage of techno-economic feasibility. We have already completed that, and we have to go for RFP process as the next step.
So
right?
this, yeah, you mentioned that the refinery will follow the API standards. Like for example, when it's come to the depressurization and the guidelines for blowdown and all the specifications that we have in API guidelines are implemented on the platform. Oh, sorry, installation or?
Yes.
Okay.
Yes. Yeah. Regarding this RFP stage, we have to follow as the next step for the expansion. Say what are the safety related aspects we have to consider before we go in for RFP stage, like calling proposal stage. That is one question I have to ask from you, because we are in the process of going for RFP after the techno-economic feasibility.
So the tender or the tender is for the feasibility study, as I remember.
No, tender for the feasibility study has already been done, and the feasibility study has already been completed. Techno-economic feasibility. Now we are going to call tenders to select an investor for building the refinery.
Yeah. So then feasibility study has not done any concept risk analysis, as I understood. So the safety buffer region, how did you establish that? What is the parameter that you use for the safety buffer region?
That was not really indicated in the feasibility study, but those things has the feasibility study says that those things has been considered, and the buffer zones has been established considering the residential nature of the area, as well as the capacity and the risk of the storage facilities maintained within the refinery, as well as the process units we're going to build in the refinery, within the refinery side. And they have been,
So
and
there's
they
not.
haven't made they haven't made like a risk contour like this, and that is not there. And that is actually the feasibility is mainly towards the techno-economic feasibility. Yeah.
Yeah. So in my understanding, I think that is the study that you have to do. I mean, like you have to perform a concept risk calculations. So this is a new plant. So you need to use, for example, the existing data from a similar plant, or maybe you can use some preliminary flow sheets and diagrams to establish the risk picture. But as I understood, this risk buffer region is based on the inventory and the general risk that you can expect. But in modern day risk analysis and calculations, and then we have this risk contours or the risk level in terms of fatality criteria. So the land usage should be based on the risk calculation or risk analysis, quantitative risk calculation, based on the leak frequencies and the consequences. I'm not really sure whether KBC is doing that. So KBC is more like process simulation company, isn't it?
Yes, yes. That
So
is
they are doing
technology and economy. That's all.
Yeah. So they're not doing risk calculations, or so that's why I think the government should contact, like for example, a company like SafeTech. Those can, we can provide a very clear picture of the risk of the new facility, and then we will perform, layout evaluation to find out if everything are located correctly, like the segmentation when it's come to different segments and how to manage the inventory. Those things are very important in risk mitigation and risk calculation. So if, for example, Sri Lanka can contact a company like SafeTech or like DNV, for example, we can provide risk analysis for the entire installation based on similar facilities and preliminary documents that you have. And that can be used, for example, to plan the land usage and also to plan the surrounding area, to if there is a need for like relocation of the people in the surrounding area, so that can be a very good document and the basis for doing that. So I think it's important to perform a concept risk calculation, because now the plant is, I'm not really sure whether the technical design have we like process flow diagrams and instrumentation diagrams, or it's just like a concept stage still.
It is like a process flow diagram, and
Yeah.
all the process units has been identified, and the capacities has already been finalized. And the plot plan also has been developed. We can use those things to carry out risk analysis, right, Mr. Dr.
Yeah, that's perfectly fine.
Yeah.
But I, as I understand, this new refinery can produce 100,000 barrels per day compared to 50,000 barrels per day existing capacity.
Yes, that's like that. It will be 100,000 new, and the existing one also will be
75 or something.
No, existing one will be remain at 50 with technical and technical upgradation.
Okay, yeah, but we can help you with that. But I think there's I don't think there's any company in Sri Lanka who can perform this kind of analysis, as I understand. But of course, we can help you. So if, for example, if you can give us, I mean, the requirements and the standards and everything that are applicable in Sri Lanka, and we can help you with the risk analysis, and we can perform a risk analysis and specify the risk contours and the other information which are required for the design
I will
and
contact
construction.
I will contact you, Doctor, on this regard. And regarding the emission standards, like we don't have sulfur recovery unit as someone mentioned in the previous question. right? And the sulfur amount of sulfur is not economical to recover also, and it is not a huge amount based on our capacity, as well as the crude oil we are processing at the moment. Because we are processing a low sulfur crude oil with very low capacity, and with the refinery expansion we will have a sulfur recovery unit, and emission standards will be met, and we will also have a plan to develop this refinery as a green refinery, and we will not use any refinery fuel. Also we will use only natural gas as a major requirement in this refinery. Those things has been considered in developing this feasibility study. Mr. Dr. Amarnath, I will contact you on this risk analysis regards for the we expect your support for us on this regard, right?
Yeah, of course, I'm happy to help through the company, and also like if you need some ideas or knowledge regarding the risk calculations and what to do, like in the construction phase or before during the concept phase, so we can have a chat and discuss.
Sometime, Dr. Amarnath, can we invite you one day to have internal knowledge session on this subject for the petroleum staff?
Yes, of course. So please let me know with some time, because for next couple of months, it's of course possible, and please let me know like a couple of weeks before the date, because next couple of weeks I'll be offshore. So I will work like 3-4 weeks offshore during April and May. But of course, it's no problem. It's a video conference system, so I can have specific discussions. Like this is today, it has been quite general, like it's a very basic and introduction to the risk calculations, but we can have quite detailed or specific discussions related to the risk mitigation, risk calculations when it's come to refinery operations. Today I have just focused on the offshore risk calculations. Onshore risk calculations are more complex and strict because of the exposure of the third party.
Yes. Okay.
Yeah, I'm happy to have a discussion. So please let me know. I can give you my email address on the chat, or
yeah. Doctor, thank you for your willingness to support us, and I will contact you on this regards.
Yeah, that'll be fine.
Yeah.
Do we have more questions?
Hello.
Yes.
Hello, Dr. Amarnath.
Yeah, I can hear you.
I am Neil Vikramasinghe, President of the Sectional Committee.
Yeah.
So, first of all, I am glad to have a meeting with you over the Zoom, and thank you very much for your very informative presentation. And we could perhaps share your experiences in Norway. I also had been to Norway some years back in 2005, and I was in Stavanger. Where is your location, please? Now in Bergen or something?
I'm living in Oslo.
Oslo.
Yeah, but I have been working in different cities, but mainly I'm located in Oslo. In my company, we have offices in Stavanger, Bergen, Trondheim, and Oslo.
Yeah, you have any contacts with the Petroleum Directorate in Norway?
We have official discussions with the Petroleum Safety Authority, not directly with the Petroleum Directorate.
This is Elinor Melby.
No, I don't have a direct contact with
You
them.
do not know, no?
No.
Anyway, do you have any past experience over any catastrophic accident or oil flame or something, or explosion, or
We have
big
been working
accident,
with.
oil spillage or something?
No, currently I'm doing accident investigation for onshore facility. We have had an experience from waste recovery system or waste incineration system in Stavanger. They have had an explosion, so we are doing accident investigation on that facility. But I haven't done, or we haven't experienced major offshore accidents during last 12 years in Norway, at least. So I didn't get a chance to do some accident investigations or something like that for offshore accidents in Norway. So currently I'm working with onshore a gas explosion accident that occurred in one of the waste incineration system in Stavanger.
If you have any video clips of the accidents, we would like if you can share with us later on.
Yeah, I can contact Chanaka on this.
Yeah, that will be very important. And again, thanking you for your valuable presentation. I hope you will be in contact with us in future too.
Yeah, you can of course contact me. So I think Chanaka or the sectional committee has my Gmail address, or if there is any any areas that you need to discuss within the risk analysis and risk management and barrier management, so you can just contact me, and then we can have specific webinars, because today it has been general with the technical and personal safety, but we can plan different sessions when it's come to, for example, barrier management and risk calculations and different aspects. So please contact me if you need some discussions or webinars that we can plan. And also maybe we can plan some physical meetings when we come to Sri Lanka, so I can inform you so that we can plan them in the future.
Because there will be some chances, there will be some opportunities for the development in oil industry in the future. At the moment, our oil trade business and everything is in trouble.
Yeah.
So
That's
get rid of it.
Yeah, we need actually influence from the government when it's come to the development of the resources and things like that. In 2011, I was invited to present at IESL, and then we discuss about the developments of oil and gas or exploration in Sri Lanka. At that time, I think the head of the exploration division from the petroleum ministry was there. But still, yeah, we need proper focus from the government, and I think they need to identify the resource pool or people with experience, and also there are lots of companies with wide experience in Norway with offshore deep water production. Like as far as I know, in Sri Lanka we have identified some gas resources with very deep water, like 1,000 meters water depth, and the reservoir is located approximately 3.5 kilometers from the sea level. So we need experience, knowledge for handling those conditions. So I'm not really sure that we have those experience in India. Maybe like Canada, Norway, those countries have wide experience on producing from horizontal wells and deep water. So I think that will be the way to go. But it's a government strategy and government, the decision to find out and to find how to go forward with the oil exploration and production in Sri Lanka. So that's very, very important. And the conditions that we experience nowadays in Sri Lanka with long queues for diesel, petrol, gas, no gas. So it's important that we have a proper plan from the government and also a sustainable plan, which is actually not changing due to the governing party in Sri Lanka. So that's important.
Yes, correct. Now you were here in 2011, no?
I have been in Sri Lanka actually January, but that was a very short visit. But yeah, what I know about oil and gas in Sri Lanka is, like all the politicians, they start talking about the gas production when it's close to the election, and after the election, and it's quiet for 4 years, and then they start talking about gas again after 4 years. So that has been like a vicious cycle, and I think that will not work. So we need to have a plan, a national plan for developing the gas reserves in India, in Sri Lanka, because what Norway has done is they have established a framework in Norway. Like, for example, British Petroleum can operate in Norway, but they have to establish their own company in Norway to operate in Norway. So that's the way of, like controlling the cash flow and controlling the income. So we need to do a similar approach in Sri Lanka, like Nigeria. They have actually they have been first with the oil production. So they haven't managed the income correctly. So it's important that we have a national framework for investing and managing the income from oil and gas business. Otherwise, it will be very, very bad, like in Nigeria and other parts of the world. So it's a national policy that we have to develop.
Well.
Yes. More questions?
Okay.
Yeah, I think we have come to the end of the...
Mr. Chanaka, may I ask one more question?
Yeah,
I'm ready to hear.
Sure, Engineer.
Yeah, if I'm not imposing on the time, Dr.
No, it's fine. Dr. Amarnath has to...
Yeah, okay. It's okay. Yeah.
Dr. Amarnath, I think we are heading in the right direction. I think your presentation has set us off on the right direction. Just a technical point. Since we are talking about risk acceptance criteria for refineries as well as for offshore facilities, I would just like to know whether individual risk contours are applicable for onshore facilities, or should we go for societal risk factors such as FN curves? Because I don't think IR alone is going to be sufficient for something like a refinery. Your thoughts on that?
For offshore installations, and there are no third parties around. Like, for example, if you consider offshore platform, and there's a very low risk of exposure in the third party. But when it's come to the gas pipeline that goes on the sea bottom or the sea floor, and then if you have a gas leak, and that can expose the ships and the third party fishing vessels, so then you need to have the FN curve to present the risk to the society or the societal risk. But when it's come to the refinery, and then we need to consider the risk contours, individual risk contours, to assess the risk to the third party surrounding the area, in addition to the risk exposure of the personnel working in the refinery. So we need to establish the risk tolerance criteria for the third party as well as the first party when it's come to the onshore or refinery.
Thank you very much.
Yes.
Yes, I think we have come to the end of the presentation.
Yeah.
Yeah. Any more questions?
Sir, if you don't mind, shall I ask one question?
Yeah.
Yeah, sir. When we lay offshore pipelines, natural gas, the buried pipelines, what is the minimum depth to be maintained when we lay such natural gas pipelines in the seabed?
In the seabed?
Just like if you just... Yeah, in the seabed, if you just lay the pipeline on the seabed, there is possibility of damaging due to anchors. So we need to basically bury the pipelines. What is the minimum?
There's no like a minimum
Any standard
depth.
for that?
No. Offshore pipelines, there's a huge risk of damages due to trawling and anchoring. So if there is like accidental drop of the anchor and then it can damage the pipeline. And also the trawling is very important, and then you have different types of trawling like mid-water trawling and bottom-water trawling. So mid-water trawling will not influence the integrity of the pipeline, but for example, bottom-water trawling, and if there is the bottom-water trawling in the area where the pipelines are located, so it can be quite dangerous. But as the regulations, you can't tell people that, okay, it's not allowed to do fishing in this area because you have a pipeline. So that's, at least in Norway, we can't stipulate regulations or restrictions for fishing activities over the pipelines because of the hydrocarbon transportation system. So the only way of doing it, we need to have rock dumping, or we need to bury the pipeline in the areas where you have shipping fairways, or like more trawling activities or intensive trawling activities. But there's no requirement for depth of the pipeline. But there are regulations relating to the free spans. Like the free spans are the suspended pipe sections on seabed. So if you have suspended pipe sections on the seabed and that has a higher potential of damaging due to trawling and anchoring, so then we need to have some rock dumping or some other mechanisms to avoid like free spans on offshore pipelines. But when it's come to onshore pipelines, there are some regulations in OGP, OGP regulations when it's come to the pipe sections, how we install onshore pipe section, buried pipe sections. In the risk analysis, there are different ways of calculating consequences due to releases from, for example, buried pipe sections. It won't be like a free flow jet. It will be more like a diffusive fire if you have a leak from the buried pipeline. But offshore pipelines, you don't have requirements for the the depth where the pipeline is located, but you have to take precautions to avoid free spans and the risk of trawling and anchoring, the damage of pipeline damages due to risk trawling and anchoring. Did I give you the answer, Mahesh?
Yes. Yes, sir. Because we basically plan to go for 1 to 2 meter depth burial. But as you suggested, also rock covering is also possible, sir.
Yeah. So the requirement is actually depending on there's not a standard. So most of the pipelines that, for example, the pipeline that I'm showing here, on the screen now. So that's the stat pipe pipeline, and the pipeline is mostly exposed. So this pipeline has a length of 842 kilometers from Norway to Germany, and most of the pipe sections are exposed. So it's just laid on the seabed, and it's not buried. It's just laid on the seabed. And at the areas where you have like crossings, I mean, like, for example, if you have a pipeline that cross over this pipeline, and then you have to have some buried sections. Again, like, for example, if there are areas where you have ship fairways or the areas with high shipping activities, and then it's very important to, for example, have some rock dumping or some other mechanisms to prevent damages to the pipeline. But as far as I know, there is no standard or the pipelines that have been working with, and they are not 100% buried in offshore pipelines or the offshore pipelines. They are like exposed to the trawling and shipping activities.
Okay, thank you, sir.
Yes.
Yes, Doctor, I think we have come to the end of the presentation. I think there's no more questions.
Yeah. Yes.
Yeah. Yeah. So on behalf of Shiksha Committee, I would like to thank you for your valuable time and the presentation and the knowledge shared. So I think we can have some more interactive session when you are in Sri Lanka next time, maybe. Yeah.
Yes.
So I would like to thank Engineer Deshaka Kotagoda also arranging and coordinating all these sessions. So this is the fourth session we are conducting with the resource person from Norway. So it's a great thing that we can contact you, and you are taking this as a good opportunity also for you to present and you to do something for Sri Lankan community as well. So on behalf of all the ISL members, so I would like to thank you once again. Yes.
Thank you very much for inviting. And as I mentioned, I will try to find the regulations regarding the the environmental risk assessment and guidelines, as Mahesh pointed out, regarding the ecosystem or the effect of the ecosystem on the power plants or the floating power units. So I will find it out and I will send it to you, Chanaka. Maybe you can share it with Mahesh.
Sure. Thank you, Doctor.
Okay,
well,
thank you very much. And
Mr. Neil?
Dr. Amarath, thank you very much for your valuable presentation. Again, we shall meet physically someday if you have time. It will be very important for us, and we have to keep this relationship forever for a long time, because we are in trouble with the petroleum trade and industry these days. We have to get many experiences, so we have to share many things with you all and get many advices and all that. So again, thanks you for your spending your valuable time and your presentation. Again, thanks very much.
As I mentioned, so we are here to have we are happy to help the country when it's needed. So just contact us, and also the if we get some chances to share the experience with the the politician and the governing bodies, I think it's important to open their eyes and plan our future for the country. Otherwise, it will be very difficult in the future.
Yes, Doctor.
Thank you very much, and thank you very much, Annika, for arranging the session and all the communications that we had during the sessions and before the sessions. So let's meet again, and thank you very much for all the attendees.
Sure.
Thank you very much, Doctor.
Thank you, Doctor.
Thank you very much. Bye-bye.
Thank you. Bye. Thank you.
Thank you.